and global collaboration across Africa, then promoted sustainable development within aerospace and energy sector. Now, for the sake of this particular meeting and probably even subsequent meeting, I have just few rules that I would love to share. Number one, please keep your mic muted. I would want us to stay conscious of it. Sometimes we might want to navigate through several tabs, especially via laptops. And sometimes I understand the fact that sometimes you might not know that your mic is unmuted. And that was why I put the word stay conscious of it. Because whenever our speakers are speaking, I would appreciate if there are no distractions during the presentation. So please stay conscious of the mic. Then, of course, we have a Q&A timing. So we have questions and answers at the end of each segment, and I give the timing for just 5 minutes. So, like I mentioned, keep it clear and concise so that speakers will also be able to give a clear and concise answer as well. And probably in the course of speaking, probably the speaker mentioned something that you want to address at that particular time. And probably if you wait till the end of the session, you might forget. You might just go to the chat section and then you drop your question. And I'm sure the team is going to flag it and remind the speaker at the end of the segment, at the end of the session, so they'll be able to answer your questions. And then also the session structure. For our speakers, we have 25 minutes. So I'll be at the back end here with the timer. The first alarm you hear is just 5 minutes reminder to the end of your session. The second alarm is for you to say your time is up, and then also for question and answer as well. And just for our learners, once again, keep your questions clear and concise to be able to enable the speakers to be able to answer this. Ladies and gentlemen, this is where I call the CEO for the welcoming address. I mean, the reason why we are gathered here, the person who has envisioned this, who has kept this going, especially for the last 2 years. I mean, the conference going for the last 2 years. So love to give him the platform, trying to give us a welcome address. And yes, we'll get started from there. Over to you, CEO.
Sure.
If you are on the call, CEO, Mr. Marvelous Ayinde, you might want to take the platform now and give us a welcome address.
All right. And can you give me some minutes, please?
Awesome, no problem.
Yamute, we can't hear you.
Thank you so much. I said, while the CEO is still settling down to give his welcome address, for those that are just joining us, yes, we are dropping our introduction in the comment section. I believe somebody just dropped his Gayatri. Hi, you're Gayatri, an aerospace engineer working on the design of extraterrestrial structures, joining from India. It's so good to have you around, Gayatri. Thank you so much for joining. Thank you so much for joining. It's so good to have each and every one of us. Oh, we now have more people on the call. Thank you so much for joining. If you have not introduced yourself, you can just go to the comment section. Tell us your name, where you are joining us from, and what you want to achieve at the end of this particular program or this particular call. So, and if you are not aware, the call is going to run for 4 days from today till Saturday. So, MARVECX, CEO of MARVECX Aerospace, if you are ready to give your welcome address, you can just give me a thumbs up so that I will just leave the mic to you. If you have not dropped your, awesome. Okay, over to you. Please go ahead. If you are speaking, you are still muted.
All right. Can you hear me now?
Yes, we can hear you loud and clear. Please go ahead.
All right. Thank you. Thank you. Okay. Welcome everyone to this year convention. I'm really glad that all of us are here. So distinguished speakers, esteemed partners, innovators, researchers, students, and professionals from across the world. Good morning, good afternoon, good evening, depending on where you are joining us from. My name is Ayinde Marvelous. I'm the founder and CEO of MARVECX and the convener of the International Space Technology Convention. It is with profound honor and excitement that I welcome you all to the International Space Technology Convention 2025. This year's theme, Emergence, reflects the moment we stand in today, a moment where new technologies, new ideas, new forms of collaboration are rising, at an unprecedented pace. A moment where young minds and global leaders sit at the same table to redefine what is possible in the space exploration, advanced technology, artificial intelligence, sustainable innovation, and the future of our planet. At MARVECX, our mission has always been clear: to create a platform that bridges continents, discipline, and generations. A platform where vision meets action, where curiosity meets expertise, and where innovation emerges through collaboration. The convention brings together a truly exceptional lineup of speakers, leaders who are shaping the future of aerospace, redefining engineering system, pioneering breakthrough in AI, and driving sustainability in technology. Your presence here reinforces the belief that advanced humanity requires collective efforts, global cooperation, and intentional dialogue. So over the next 4 days, we engage in deep technical session where our participants will learn the fundamental of rocket science and satellite manufacturing, led by one of our partner companies, STAR, that is Space Technology Aeronautical Rocketry from India. Groundbreaking panel discussion, cross-industry presentation by experts in the aerospace and technology industry, and creative showcase through our CI show segment. These sessions are designed not only to inform, but to inspire, challenge, and empower each participant to contribute meaningfully to our shared future. To our partners, STAR, Space Technology Aeronautical Rocketry from India, and the radiation team from United States, your commitment and collaboration have strengthened this vision, and we deeply appreciate your support. To our speaker, thank you for lending your voice, expertise, time, and to this global conversation. In terms of Dr. Ashwarya, I think she's on call currently, and Mr. Ruga Hall, yeah, I think is also on call currently. So thank you for partaking in this year's convention. We really appreciate that. And to our participants, your curiosity, passion, and dedication are the true driving force behind this convention. As we begin ISTC’25, I encourage every one of you to stay open, stay engaged, and stay inspired. Ask questions, connect deeply, think boldly, innovate fearlessly, because the future we are preparing for will be shaped by the ideas and connection we build here. Let us step into the moment of emergence together. A moment where innovation arises, a moment where leadership emerges, a moment where the next chapter of space and technology begins. Thank you, and once again, welcome to ISTC’25. Let the journey begin. Thank you once again.
Thank you so much, Marvelous Saidi. That is the CEO of MARVECX Aerospace. You might just just give a virtual round of applause for such a wonderful welcome address to us. Thank you so much. Yeah, I believe I might just want to add this to one of my housekeeping rules. Whenever at the end of each of the wonderful speech letters, I would appreciate flowers. I would appreciate virtual claps. You can just make use of the emojis. Just be next to your screen. Make use of your virtual claps. I believe it helps to boost the morale of the speaker. Make use of your flowers, especially if you just learn something insightful from each of the sessions. It's actually go a long way. For those that are just joining in, you're welcome. Thank you so much, Triparty. I hope I did get that. Yeah, pardon me. I guess I would have to apologize beforehand. A couple of names that I might have to learn probably at the end of this call, but from the beginning, you might have to forgive me, especially with the pronunciation of the names. So yeah, for those that are just joining us, you are welcome. Welcome to MARVECX Aerospace. And then yes, we've given some couple of housekeeping rules. I say yes, just keep your mic muted. And I just added one, make use of the virtual claps and make use of the flowers, just so you just keep, just so you engage and just so that the speakers will know that you are there with them and then you are following them and then yes, you are learning from them. So yeah, without further ado, our speakers are well seated. And then yes, I would want to also go through the event program once again, especially for the benefits of those just joining us. How is this program going to go? I'll go through that. Then I'll be introducing our guest speakers for today. Nice. If you can see my screen, I believe you can see my screen. So the event flow for today, we have our welcoming ceremony, which we're doing. Then the opening address, which has been done by the CEO, Marvelous Anyede, CEO of MARVECX Aerospace. We'll be having our keynote speaker, will be coming in any moment from now. We have our keynote speaker too. We have our break. Our break is just for 15 minutes thereabouts, where you might just, we call it coffee break, where you just stretch your leg. You can use that to just reflect on what has been said, or you can just do that to document any of the questions, any questions that come to mind. And I just do well to just use that to probably document whatever challenges you are facing, and then use that button to just reflect on anything that has been said or recorded, and you might want to apply it, in your workspace. So, because the main reason why we are gathered here is for empowerment, one of the core values of MARVECX Aerospace, empowerment. So, and the empowerment is not complete without application. So, I believe whatever has been said today is something that you apply, probably your place of work, probably your studies, probably your research. So you might just use the break period to just reflect. Then we have other keynote speakers that are well seated. Once again, you are welcome, each and every one of us. So I've gone through the mission and vision. For those that are just joining us, you may just go through the website, www. I believe it's going to be dropped in the comment section. You can just go through all of this once again. So yeah, our first speaker for today, I noticed while I joined the call, our video has been smiling at me. You have such a beautiful face, ma'am. Dr. Dara. Dr. Dara is an excellent academic and researcher, currently serving as an assistant professor, Department of Aerospace Engineering at Hindustan Institute of Technology and Science. Also acting as the founder of Academic Innova. So this is where I stop presenting my screen so that I'll know those that are clapping. Because while I read our portfolio, I would appreciate if you give round of applause, because this is a wealth of portfolio. So while I read that, I would appreciate it if you encourage and you water the stage with flowers with round of applause. Yes, let's keep that coming. Let's keep that coming while I continue reading that. So yes, what has she done? She has dedicated her service for more than 11 plus years in the aerospace domain. She has authored 3 influential books: Essence of Aerospace Engineering, Aircraft Design Guidebook for Freshmen, and Overview of Aero Modeling. Interesting. Her contributions have been widely recognized, earning her accolades such as Kalpana Shola Award and the Best Teacher Award. So we are in here for a teaching session, for a learning session, because yes, we have an award, a Best Teacher Award in the house. I would appreciate an applause to that. Awesome. Our research is at the forefront of industrial engineering innovation, with a focused interest in the application of artificial intelligence and machine learning to aerospace vehicle design, including aircraft, UAVs, and rocket thrust chambers. She leverages multi-criteria decision-making techniques for design optimization, a theme central to her PhD thesis on machine learning-based design for wide-body aircraft. Her prolific research output includes various publications in reputable international journals, and a seed fund project on drug prediction modeling. As a recognized HAL Innovation Vision Mentor of Change, she actively guides students and aspiring entrepreneurs, fostering a spirit of innovation. Dr. Dara is a dynamic force in aerospace education, a skilled educator, and innovative researcher at the intersection of AI and aerospace, and a dedicated mentor shaping the future of technology and its entrepreneurial applications. Ladies and gentlemen, yes, in a couple of minutes, I'll be leaving the platform. So the person whom I just read this portfolio, you might just do well to get your learning tools, your pen, your journals, because yes, we are yet to hear from another best educator all the way from India who has won several awards, and then yes, she's ready to deep dive into AI, machine learning from a wealth of experience, and also aerospace engineering, among other speakers that will also be speaking in the words of experience. Like I mentioned, if you have any question at the end of our session, you might just do well to make use of the chat, and we can just spend 5 minutes at the end of our session where you can ask a clear, concise questions, and I'm sure she's going to do justice to that. Dr. Dara, I believe you are ready for us this afternoon.
Yes. Thank you, Esther, for wonderful introduction. And thank you.
Awesome.
I'm really glad to be a part of this conviction and to insights and wonderful insights on the current booming technology, that is AI and machine learning in industrial application and concentrating on aviation sector. Yeah.
Awesome, Dr. Dara. I just want to reiterate on how the segment is going to go. Like I mentioned, 25 minutes session and then 5 minutes for question and answer. So the first alarm is just to maybe highlight you. Now you have 5 minutes at the end of your session, then another 5 minutes to wrap up, then the question and answer comes next. I hope we good. Yes, please, you can go ahead.
Yeah, thank you so much. Thank you. So I will start with a basic presentation where some of the infographics will be there. So I think my audience and the learners can, get used to with this thing. I hope my screen is visible.
Oh, yes, it is visible. You might just want to present the full screen. Awesome. Yes, we good.
Right. So as my topic will be fully concentrated on AI and machine learning in aviation industry. So I'll be highlighting some of the real case study. Now the question comes, the why AI and machine learning that right now is booming. So you can see some of the graphical representation, the growth rate. In 2030s, it is going to hike just 48%. Now, looking to the next understanding that what is machine learning. So, if you are very new to this machine learning, artificial intelligence, deep learning, now the era of this deep learning, machine learning, it's an internal component of an artificial intelligence. Artificial intelligence stand on the basis of deep learning and the machine learning. So by the name, it is very clear. Deep learning means very keen or going very deep into it, and you're making anything exactly like that, just a replica. If I scan something and if I make a duplicate of that, it will give me the same exact result. In order to make exact result, what I'm doing, I'm doing a machine learning techniques. I'm using some statistical methods. So as a result, those parameter and statistics, I am getting an artificial intelligence, just a duplicate of it. So that is a basic understanding of AI, machine learning, and deep learning. So I would like to take you or walk you through that how this machine learning creating wonders in different sector. And I will also walk you through some of the statistics, that is, how the growth rate of this machine learning and how these industries are working. So this is a recent article released by this International Civil Organization in August 2025. So you can go through, scan and go through this article, how it plays a very, very impactful scope and the prospects and the challenges in artificial intelligence on aviation sector. Now, everywhere I'm talking about aviation sector and artificial intelligence, here I will also walk you through some of the graphical representation, right? As you can see how drastically researchers, scientists are working on this AI. So now I will come to the core element. That is, what are the areas that as of now, this AI and machine learning is being utilized. So here I'll be focusing around 9 to 10 areas. As you can see, some of the area like airport management, air traffic management, logistic, flight operations, maintenance, human factors, environmental, and also for the training. This is just an ground operations in airports. But apart from that, engineering level, other industries, it also creates another booming sector. Now, before we get into this, all those things, I would like to highlight how this AI can also boost up this aviation education system. So when we talk about this aviation, aerospace, or defense technology, the word is very simple. But when we go deep inside of that, it's more complicated. Now, how we can make this complicated study in a very simplified version? So AI can help on those kind of platform, creating a gap between, prototype or the pedagogy of teaching, or understanding the concept using AR, VR, 3D simulations. So such kind of areas, the AI can bring a revolutionary act on this. Not only that, as this convection is also a part of this sustainable development, I would like to highlight this SDG 4. SDG 4 says that it's a digital education, where how this AI can bring a better version of education in terms of learning, and a very impactful learning. So as as I've shown some of the statistics and this video, it is clearly understandable using VR how we can, really physically understand and study this. So same technology can be used for the trainer for the practicing of the training. So a lot of economy can be saved by an effective learning process. Then AI can also benefit in design, not only design in aerodynamics, structural, right? So it can also help to reduce the computational time. We know when we are analyzing any component through computational fluid dynamics or finite element method, the computation time is huge. It can take 24 hours or even more than that. So this machine learning can impactfully reduce this computation time, and can also provide effective design concepts. Coming to this passenger experience and airport management. So highlighting, as you can see, that again, when we talk about the ground station, human factors, human error plays a very, very crucial role in airport management, as there is no room for mistakes, right? So there are a lot of process when we like point of checking till we board. So such kind of this process can be tracked, can be reduce the human error a lot using this integration of AI. Not only that, it can also help. There are some researchers, they have studied the route, effective route analysis, so that the flight, how we can reduce the emission of it using machine learning techniques, how effectively we can make the flight operators so that the economy will be rising in the airport management. So a lot of studies, not only in the human error reduction, but also fuel burn, and also effective flight operations, and also the routing management. Yes. Now, similar to that is an air traffic management and safety. So when we talk about aviation, safety is one of the key elements. I hope all should agree with this point. So how does, during pilot, if the pilot is flying on board, there are certain decision-making scenario that a pilot need to take. So such kind of systems are being integrated, so that even some systems is getting failed, there are other AI-based redundancy process, how we can effectively save the life of passengers and also the crew members, right? So this is one of that. And air traffic management, as you can see, there are space is getting, clutters, a lot of vehicles, like the core countries, if you see the flight plan and all. So how effectively can manage all the flights, right? Decision making supports predictive risk, reducing the accidents. AI can do wonders, and there are a lot of papers available on such relevant areas. Now, predictive maintenance. This is another very recently this maintenance and MRO people are using on this very effectively, and through digital twinning and other process. So it has also been reflected very efficiently, like predicting the component failure. So they are analyzing this particular component, at what level it is going to fail, what are the scheduling the maintenance, like alarm will be popping up, so now this is a maintenance should be done. So likewise they can able to reduce the operating cost a lot. So this predictive maintenance using AI and machine learning, so a lot of like Saffron company, Boeing Analytics, there are other companies we are tying up with the other third party companies, so to improve their predictive maintenance on that. So this also shows a very effective applications on this area. Yes. So now this I will say, as of the current trend, this is playing a very, very major role, and it is very open to all industry. So first is a autonomous system and UAV applications. So as we know, the name autonomous means we are programming it, and programming is based on our requirement, if based on the flight, whether it is underwater, inspecting traffic, or only inspecting solar panels, or inspecting the pipe inspection in the industry, or industry patterns, and so many other options, right? So autonomous systems are widely used, and this system is not only used in industrial application and very keenly used in defense system as well. So highlighting this, my presentation will be more going deep into it, how this AI system can really helpful, especially on this drone sectors or the defense sectors or in the autonomous any region. Now, what are the things can be done using this autonomous system or UAV implementation? I've given some of the highlights over here. That one is an autonomous taxi, as I think recently one of the US company has started autonomous human vehicle, not an unmanned aerial vehicle, human aerial vehicle, where the entire body is made out of composites. Only two people can sit, right? Then is a sense and avoid system. So using AI technology, it can do wonders. I will show some of the examples how they're working. I will give you some of the real-time examples. And swarm intelligence for UAV fleets. So as you know, swarm intelligence not only for defense but also for recreational purpose, it's doing wonders. So I think you have seen in last year in Dubai how they're making a recreational environment using swarm intelligence UAV. Then of course surveillance is also taking place in different other places. Now this is an like you can see one figure, and the question is that what's the need of machine learning in this integral part? Now I will give you a small situational questions to make you think about it. Now we have here the question is, an operator watches a single UAV feed over 50 miles desert border. Okay. After 3 hours, they are fatigued. They might miss a small group of crossing during a moment they glance away. So keeping up one single person taking care of single UAV for 3 continuous hours at a time is really tiresome, right? So what this AI and machine learning techniques can do, they can have GCS system, that is ground control unit system, right? So integrating around 4 UAVs across 50 miles each. So 4 UAVs has been integrated. Each will cover 50 miles, right? Each will cover 50 miles. And from there, a single operator can see that what are the activities happening. So UAV 1, if it is no alarm signing, that means, and showing a green color, means no movements, no anomalial movements happening. But if it pops up with an alert button with a sensor buzzing some sound, and they can also track the person when there is a movements along this unwanted area. So alarm is popping. Another orange button if any animals has been moving, right? And again, the fourth one is again the green. So what you can understand from here? So what you can understand from this particular scenario, using machine learning, you can reduce a human effort. On the same time, not only that, but also it will give you alarm, signing alarm, and you can do more effectively rather than going with a conventional method. So this is a wonders of machine learning. This is a small um, example. So likewise, I will take you through some of the idea behind machine learning if you're very new. So to work on this machine learning, definitely after this presentation, I will expect at least some of you will at least think to start working on machine learning if you have not really started on. So to work on this machine learning techniques, the first and foremost thing is that requirement is that historical data, or you can say data. So now when we talk about data, what type of data means? It can be labeled data or unlabeled data. So when we have labeled data means, so here we can work on the supervised learning. If you don't have like labeled data, like kind of you have an unlabeled data, so we have to work on unsupervised learning. Very simple on this point. Now, what do you mean by labeled data, right? So what do you mean by labeled data means, suppose you have a data, your aircraft, you have this particular aircraft, what is the payload, you have the thrust, you have the engine, right? You know, this is a thrust, 125 kilonewton. You have the propeller using, this is the power of your propeller. Then you have the battery capacity, how much time it is enduring, what is the velocity of that particular. So likewise, you have different kind of set. So you know the number 125 means it's a thrust kilonewton. So that is defined by the label data, the value that you have. So you know what is it, what that value defines. Unlabeled data means some random numbers are there, 125, 0.23, but you don't have any clue what that value is. So that is mean by unlabeled data. So when you have a statistical value based on data, so it's very clear and simple that if the data is labeled, so you have to work on supervised. If it is not, then unsupervised. But if it is a mixed of some labeled data, some unlabeled data, so you have to go with a supervised learning. So I'm not going with the reinforced. So as a beginner, I will just focus on those. And now there are different types, different researcher daily, they are innovating different techniques. And some of the very used technique is this. So if you're very new, you can make a look of it, regression, then principal component analysis, neutral networks, random forest, and so many. These are the most commonly used machine learning algorithms used by the researcher. Now, this machine learning, how it is used in defense. So I will walk you through some, real-time cases, how actually it works. So now you have a camera integrated UAV, and you have pre-planned programmed with an image process that this is tank and this is truck. So this is a civil truck means don't shoot. And if it is a tank means you have to shoot it. So sensor is capturing a data and giving you the value. So whether this tank means our enemy and truck means our friend. So don't shoot, and when to shoot and when not to shoot. So such kind of tactics, a very simple example, can be easily done using machine learning. So no need to go, I'm not going much deep into this mathematical expression. So if you have any doubt, we can look into that in the later part. Another technique, another problems that can be solved. So you have a UAV. When you're launching or you're returning back to base, so many situations can it happen. So you have programmed that where this UAV should be land. Okay, so we have given in the data, we have trained our camera through the camera that this means open area, this is water body, this is forest, this is urban, and this is rough terrain. So which one is safe to land? Obviously, safe to land is going to be an open region. So now I'm training my UAV where in the typical situation, suppose an UAV is in mission, I have programmed from some 200 kilometer away that to perform some mission. All of a sudden, some issue with my battery. So battery management I have not worked on. So battery is just going to sustain for 15 minutes. So I have to save my UAV. So what is a safe pace for my UAV or the drone to land? So whether it's open area, forest, water, urban area, or the rough terrain. So how it can locate and correctly, safely, it can land. So such kind of complicated typical situations, it can make its own decision. They don't need, you always no need to like work on this. So it has a capability, it has a mechanism. You're training the model such a way that it will have an memory to do what is right and what is wrong. So such kind of training can be done in different methods, right? So how we know the method is right? You can use random forest, you can use logistic regression, you can use other technique. So this can be done using the accuracy and precision, right? So here, based on the testing data, we can see the accurate prediction is out of 250, 190 accurate and 60 is fail. So it shows that how our model is accurate. It's just 88.5%. So not 100%. So we can look into other algorithm and see which one is giving the better. We have to opt for that. Okay. That's how this machine learning works. Now, as I've said, another typical situation, there is a high threat and you have to return to base, right? So which is the shortest path will you follow? And you have a very typical battery, okay? Within 15 minutes, you have to reach your destination. So this UAV has a memory. So how effectively and quickly it can go back to its base. So such kind of programs can it done. Now, I will also give you some idea how this unsupervised learning works in this. So as I've said, unsupervised learning is basically work on this unlabeled data, where the numbers are coming randomly, but you don't know what the number is.
Hello.
So how you can work, suppose here is a UAV, you have multiple sensors. You have a video, you have a IR sensor, radar feeds, so many sensors. So you're getting a different types of data. So how you are going to work on those? So on that kind of scenario, you can use unsupervised learning. Okay. So not only that, there is another technique called principal component analysis. It's a type of unsupervised learning. So what happens when you're capturing or values are very huge? So that can convert in a small scale matrix without changing or altering the parameters. So this is again an innovative technique, a statistical technique. So such type of technique is also used. Yeah, this is very interesting. This is mostly in the defense sector. Usually they use this. In the current scenario, you might have seen the wars happening across different countries. So what is a supervised learning? Here we have in our UAV some data we already fixed. Okay, this is tiger, this is dog, this is deer, this is different animals we have feeded. We have also feeded, which is our civilian truck, friendly truck, right? This is our regular patrolling cars, patrolling other things. We have feeded. But what happens? Some are capturing the data which is not matching with what the data has been fed. So those data comes under unlabeled data. So what will happen whenever something unwanted things happening? So it will buzz an alarm, right? So it is a self trend based, right? So such kind of concept, or such kind of when you have both labeled data and unlabeled data, and you have programming that which is unwanted thing and to pop up an buzzing sound, so you can work on this semi supervised learning, and this is drastically used in this border area and all. Now, I would also like to highlight on this snooping detection. Now, snooping is nowadays is one of the greatest crime, or during wartime, it is one of the tragic, and it's happening drastically. So what this snooping is, that basically it is giving a false detection of that. Suppose a vehicle or a flight is flying at some altitude, okay, and with some certain latitude and longitude, but in the radar system it is not giving the exact value, it is giving a false value. So what will happen, it might very difficult for the pilot to exactly calculate and land in a proper perspective, and also the engine play a very vital role just before it lands. So such kind of fake signal they are receiving, right? So which leads to and false positioning of the flight. So this is drastically happening. So using AI techniques, some of the algorithms, we can really jam those false signals, and we can safeguard from that. So it is one of the highly used in this defense sector. And also you can also fool your enemy flights, or also the UAVs, so using this snooping technique. So nowadays anti-snooping detection techniques are also going to launch very shortly. So this is right now as the biggest crime going on, this on snooping technique. And there are other future like prospects I would just like to highlight. So one of the biggest thing is that with the small data, we can train the data in such a way that it can predict in the earliest. So likewise, surveillance, object detections, energy management, one of the key area. Like prior to that, they will give an alert that this much warning sign, early warning signs of your battery management is one of the very, very important area that using machine learning, you can improve it. Image processing, image enhancement, video enhancement. Then we have environmental monitoring, right? Drone swarm security, the cyber security, and those early detections, right? So I think I have walked you through those basic region. So if you have any questions on this further techniques, I'm open for the question. So I'm ready to answer for it. Yeah. And before that, if you're really new to this AI and machine learning, so through generative AI, you can also learn. So if you really want to learn, here is the scanner. And further applications like other industrial, like pipe inspections in biomedical sectors, they're using AI and machine learning in those areas. So you can scan this, right? So yeah. So I think I have covered a basic outline about this AI and machine learning in aviation sector. Yeah, I'm open for the question.
Thank you so much, Dr. Dara, for this.
Yeah, thank you.
Yeah, so this is the segment for question and answer. If you have any question concerning what Dr. Dara said so far, you may just do what to ask. You may want to raise your hand, or you might just want to drop it in the comment section. If you have any questions, if you need any clarity, is there something she said that you needed her to explore more, although she has given us a scan code. Probably you may want to explore more or deep dive, but if you just want maybe like a sharp and concise answer to any of the questions, I would appreciate you raising up your hand, or you just drop it in the comment section so that we'll raise it. And I'm sure she's going to do justice to it. Mr. Tinashe, do you have a question? Hi, Mr. Tinashe.
Okay, I think there is a question. In your border patrol case, one operator manages 4 UAVs covering 200 miles. However, in actual deployment, how do you network latency and bandwidth limitations affect this ratio? Do it. Okay. So yes, yeah, it's a very good question. That how this network literacy and bandwidth limitations. Yes, so that's why it comes under this ground control unit system. So understanding the radius, the coverage, the bandwidth, right? Everything comes into this other different system, right? So based on that, they are working on it. So yeah, I think I have covered that.
Yeah, thank you so much, Mr. Dara. I don't know. Tinashe, you were trying to say something earlier. I don't know if you still want to speak, or you might want to try muting now and then ask whatever question you want to ask. Jensen, I want to believe your question has been answered. If you have any follow-up questions, we still have the ground open for you to be able to ask any follow-up question. Awesome. Thank you so much, Francis, for sharing the resource that people can actually check at their free time by Dr. Dara. Thank you so much.
Thank you. I'm really happy to be here. Yeah. Thank you.
Thank you, Dara.
Yeah.
Okay. I'm still trying to leave room for the next 2 minutes. Probably people are trying to reflect questions, or for those typing, to still be able to come up within the next couple of minutes. Awesome, awesome. So for those just joining us, probably when Dr. Dara was speaking and just joining us, you're welcome. First of all, you're welcome. Thanks for joining MARVECX Space Convention. And like we mentioned, it's a 4 days program. This is the first day. The maiden day. Thank you so much for joining. And then yes, we have a couple of events lined up for us. And then we just finished one of very massive and then enlightened session by Dr. Dara. So we have a high number of speakers that is lined up for us. And then yes, we're in the session of questions and answer. And then so far, I want to believe all questions has been, this session has been clear enough for us having a question, and whatever question that has been asked is already answered. So for subsequent sessions that will be coming up, I have a very, very small assignment for us. After each of the session, you might just go to the comment section. And then you just type, what are your key takeaways from the session? What actually stood out for you from each of the segments? You can actually start from Dr. Dara. You might just go to the comment section. What are your key takeaways from each of the session? It doesn't have to be a paragraph, just few sentences will do. Thank you so much. So yeah, we will be going to the next speaker. However, I have a disclaimer. Let me just share my screen again. I have a disclaimer to share. So here is what I shared at the beginning of the call. That will be our event flow for today. Okay. So I mentioned we had our welcome ceremony at Hopefully. We've had the speech, keynote speaker from Dr. Dara, and then we also have other speakers. However, we just got a notification from one of our speakers, which is our keynote speaker 3, Solomon Hapiki, who will not be available today for this particular session. However, whatever is going to take place should be communicated before the end of this call. either it is postponed or we'll probably have a subsequent session to cover a session. It's going to be communicated duly to us. But I just want to send this disclaimer that the keynote speaker for the third segment we'll be having is currently unavoidably absent. So, however, we have a wonderful speaker, Rafael Harilo, right on the court. So, in a moment, I would be reading this portfolio. As you can see on my screen, yeah, we have Rafael Harilo, who is the founder and partner director of Stardust Consulting, where he provides expert advisory services in legal practice, regulatory affairs, and space and aerospace management projects. Again, I'll stop sharing my screen here because I was expecting applause, and I don't think we are giving applause. I think I gave that shirt housekeeping rules. So for every of our portfolio that is being read, for every portfolio that is being read, I would appreciate an applause because I believe it is not easy to actually bring about this wonderful people with wealth of experience to come speak to us, to come share from the experience. So I think we might just want to water the floor and give them a round of applause for this particular session. Oh yeah, Raphael.
Perfect. Thank you very much. First of all, I like to give thanks for the organization for inviting me to this amazing opportunity to explain something. As Esther has explained, I work mainly about the space activities. I am not a doctor, I am a lawyer of battle. I am working all the days with private companies, public administrations. I am in very real contact with all the problematics about the space activities. I believe this is important because it's not theoretical. They are real things that all the day I'm going. When we're talking about...
sorry, Raphael, sorry. Before you proceed, I don't know. I actually did finish reading your portfolio, but it's fine. I just wanted to just remind you on the timing. It's just 25 minutes and then 30 minutes for question and answer. And I just want to round up with your portfolio so that people will know your wealth of experience and know where you are coming from. I think you mentioned about law and then also, yes, a licensed private pilot reflecting his personal passion and commitment to the field of aviation and space exploration. Because some people might want to have questions as regards your portfolio. I want to ask that. So, I mean, your portfolio actually give an hedge as to who to answer whatever questions they have in mind. But yes, I think you can have the floor now.
Yes.
But
yes.
yes, it's 25 questions.
Exactly. I share things about the explanation and free time for questions. Well, when we're talking about sustainable space technology, emergence, innovation, is from the legal point is very important things. Remember that talking about the space activities in the Outer Space Treaty in 1967, they talking about the collaboration, the mutual help, and they take in reference with the space activities that these space activities is hard and dangerous activities, and there are more possibilities to working with emergencies in any case. This is very important because more of the regulation and more of the activities, they are in direct relation with this concept. After the Outer Space Treaty in the 1968, they are the rescue agreement. They are focusing in all these possibilities to have an emergency with astronauts, with spacecraft to recover them, and they are very, very countries, they are ratification of this agreement. For this reason, in space law, the question of emergency and situations that they need to have is very, very important. But also, the question of sustainability, space activities, they are also more important and always in reference to the emergency system. When we're talking about sustainability activities, we are thinking about to maintain the actual possibility to use and develop space activities in the future. We need to take care about all our actuations in the space, because it's not only for us, it's for the future generations that we need to preserve the space increasing the activities, obviously, because by the moment when we're talking about the space activities, innovation, we need to take care about the concept of new space economy area. I remember several years ago in International Astronautical Congress in Beijing, Mike Golden, Charles Bolden, the older NASA administration, say very clear that the low orbit is a new economical development area. NASA and other space agencies need to work for propulsion, exploring the solar system, but not for launch satellites for watching TV. This is a question of private companies. Now, this is new space economic area is not only limited to the LEO. It included the concept of cislunar space. This cislunar space included the Earth, the orbits in the Earth, the Moon, orbits in the Moon, the surface, all the trajectory between Earth and Moon, and the Lagrange points. As you know, they are these points in the space that you can put on a space object to maintain certain equilibrium. That is a very codiced places. Well, you have a bigger area for to develop these space economies with the possibility to develop sustainable activities, and also is a place when the risky activities, they are very important. In fact, last year, the American Space Force declared that his operator field is not the orbit of the Earth. They included all these cislunar space activities to help the American companies to establish economical activities in the Moon and in the orbit. This is very relevant question because there are more countries in the Earth with the Space Force, but only a few, maybe only the Americans, have a full capabilities to operate in this protection about the space economy. And they give more possibilities to have situation of emergency about, because there are a lot of space activities that we can see. This development of innovation that included, for example, the question of new launchers. In some countries, they are developing more powerful launchers. In the United States, they are real amazing things between the SpaceX, Blue Origin, and other private companies like Boeing, Lockheed Martin, developing medium and bigger launchers for not only go to the space, but also go to the Moon and remain in the Moon. In Europe, for example, as you know, we have Ariane 6, big launchers, medium launchers, bigger, and now they are developing the different micro launchers. Only a few days ago, we make the ESA symposium in Bremen, and we obtained a very hard budget for develop, between another things, this technology of launchers. Inside this group, Spain, for example, have the option of Miura 5 of PLD company for to develop launchers. We have now several countries that they are with this capability, around 10 countries, more also India, Japan, South Korea, that they are working so hard to have this opportunity of sovereignty and capability to go to the space. Few weeks ago, Spain developed his national security strategy, and they declare that to have launcher and a spaceport is a relevant point in the national safety strategy, because the access to the space is very important. Well, the access to the space included that a lot of countries, they are developing these activities, and they increase the risk of collisions, re-entry without control. This is one of the reasons that they need to have very clear regulations about this. But not only the launchers is relevant in the question of development of innovation and the points to take care about risk. Also, we have and we need more spaceport. We need a spaceport worldwide, not only in the countries with capabilities. The fact spaceport relevance, they are in the United States, they are the European spaceport is in this moment in Kourou and French Guiana and the north of Brazil. They are a spaceport in India, Japan, Korea, but there are a lot of countries, including Europe, Africa, South America. South America, they are only two options with a spaceport, but we need more spaceport. Only in the United States, they are around 60,000 satellites in provision to launch. Without the capability to have more launchers and more spaceport, the option to put more satellites in the space and to create a space economy that includes seasonal space is very hard. We need that in other countries, in Africa, in India, in another place, they can develop safety infrastructure or to launch a spaceship to the space and promote this exploration and developing of economy about. But also, we need to have some regulation for avoid all the possible problems that the people they are, because during a lot of years, when we're talking about the space activities, we are talking about to put one satellite in orbit, exploring solar system. Now, they are working about constellation, huge constellations. There are companies with thousands of satellites, and now we are passed from 3,000 to maybe 8,000 of satellites. Maybe the most important part is from SpaceX, Starlink constellation. But there are studies that for the next 10 years, probably there are more than 100,000 satellites in orbit, included all the satellites we need to put in orbit of the moon or the future space. All these satellites, all these constellations give us more problems about the possibility and risk about future collisions. And one of the problems that is more severe for us is the space debris question that I talking after that. But they are not only constellation of satellites, they are the projects for to put a lost 4 or 5 more space stations. Actually, all the people is talking about the International Space Station, but remember that also we are the Tiangong Space Station with between 3 and 5 Chinese people working in the space. Well, if we put more than 4 stations, including if at the final of this decade we fall down with the International Space Station, probably in the near future, there are more than 5 stations with people in orbit of the Earth. This is also a question of risk, a possibility to have emergencies about the system. Remember that the last week we have a very interesting question about space dangers and emergency when a space debris crashed one window of the Shenzhou spacecraft. They are docking in the China's space station. Well, they are the risk always to have a space debris in collision with a space object, but this is very clear. One little space debris crashes the window of the China's spacecraft that they can use for return the astronauts to the Earth and put the risk, very risk the crew. And they, in a very short time, they launch another spacecraft they are preparing for this, and they can recover the crew. But if they are not opportunity, we are talking about a very risk. And they are obviously very critical situation about this emergency question about space debris. It's very important working with this because they are not only talking about lost one satellite. We are with the possibility to lose life of astronauts in orbit. now in orbit, and in a near future, I hope in the surface of the moon. And in the surface of the moon, any possibility of rescue or data sustain in case of emergency should be very, very complex, because we need to have a flight of a spaceship ready for to help the people they are in orbit of in the space. Also, when we talking about these new innovation projects, we are talking also about ISAM in the space assembly and manufacturing activities. We're talking about the possibility to create not only a space station, we are talking to create factories in the space, to prepare shipyards for future spacecraft to develop from orbit and from the moon for exploring the solar system. The most possibilities to have activities in the space, they included more capabilities or risk that we need to have under control. For this reason, all these kind of activities that in the past they are not more regulated need to be now regulated, including for the safety, because it's not question, in my opinion, to take something law from different texts and adapt it. We need to have a real legal framework that gives security of people in the space. And if we included the people that should be in the moon on the future basis, this should be more complex. Americans, they are talking to launch Artemis 2 in February next year. This is only a flyby in the moon. They are not the option of the descent. So they need to waiting for 2 or 3 years more. And the NASA is talking about to return to the moon before the end to the decade. But the Chinas have the same idea to put a Chinese astronaut in the surface of the moon before the final of the decade. The question is that Americans have some problems about the system of lunar lander, the space suites, and the China is step by step developing all the technologies, supporting the gap they are in technology between the Chinese and American, and they probably give a surprise if they continue working about this. Put people in the space is very complicated, but for the next 20, 27 years, India also announced the possibility to put 4 astronauts in the space using his own capabilities. This is very important because until this moment, only Russian, American, Chinese have the direct possibility to put people in the space. Now, with the proximate option of Indian space, people in the space should be very interesting. And in Europe, we remained waiting for to develop a crew spacecraft for arrive to the moon and arrive to the space. They are more activities, and as you know, only the 30% of the space activity is in relation with upstream activities, launcher, spacecraft, go to the space. 70% is applications that develop people in the air that probably they don't need to go directly to the space. They can use the information that satellites give us and develop also this economical way. This is very important because of the final, there are more activities linked with the space activities that they are in increase at this moment. Sustainability approach is the way, but they need also regulations. Regulation, in my opinion, need to have a balance between the fact to give rules and don't blocking the options to develop space activities. If we put a lot of regulation, should be a problem, but we need to put something at this. There are different examples of these regulations for to have a more safety and sustainable space. For example, no more time ago, the FCC, the American Authority about Telecommunications, established that only 5 years after the satellites finalize his life, they need to come back to home. Only in 5 years. Before, the regulation is 25 years. This is for avoid the amount of satellites in orbit. If your satellite finish his ultimate life, they need to fall down to Earth, and they need to include it for this or propulsion, or to have in a very low orbit for the drag and return. This is very important because in the development of a new satellite, they need included propulsion for make this the orbit and return to the Earth. Also, if the American authority, they are giving authorization for all the commercial activities, they are also studying the possibilities that all the launchers, all the rockets have system for the orbit or for go to the another place for avoid collisions and for avoid more space debris and for avoid uncontrolled return to the Earth. Probably a lot of countries follow these regulations at the same way that now they are following the FCC regulation. And this is important because for a lot of countries without the space capabilities, they need to build his satellites under this regulation, because if not, they don't fly in the American rocket. And normally the rest of the countries with rocket, they are including this for mitigation the number of space debris. We have in the same line between Europe and the United States, and probably using the COPUOS and the NOSA, the Office of the Space Activities in the United Nations, they are studying the same line to procure this study of safety debris mitigation and to contribute to avoid possibilities to have dangerous situations in the space. I was talking before about the space traffic management. It's very important because with a lot of satellites, should be necessary to have control, not only have the localization using the register of satellites, you have control about, and it's very important that this control should be global, because if only one country of little countries, they are working with space traffic management, is not complete. We need that all the people, they are space activities, contribute to have a space traffic management for avoid collision, to avoid Kessler syndrome, and to give more safety for the space activities now that we put more satellites in orbit, and we will put more people to orbit, to the space station, and to the moon. They are, as you know, two international initiatives. They are Artemis Accord and the ELRS Accords, one from the Americans and allies, and another from China, Russia, and the rest of the people with more or less the same political ways, that they are working to make this special instrument or to make new regulation. But take care, because, for example, Artemis Accord, they are political, not binding agreements. Only if they need to develop a specific area, should be necessary to create a specific legal binding instruments between the different countries. Artemis Accord, they are bilateral accords between United States and, at this moment, 60 countries. They are more countries, they are joined to Artemis Accord in only 5 years that the countries they joined to the Moon Agreement in 50 years. They are only 60, and Saudi Arabia withdraw for the Moon Treaty and go to the Artemis Agreement. And in the relation to the China-Russia Agreement, the ELRS, they are 70 countries and more than 50 international organizations. This is the idea that a lot of countries like to work extra United Nations treaties to develop this system of particular framework about the space. And in Artemis Accords also, they are reference to mutual collaboration, actuation in case of emergency, etc., etc. It's very relevant for all the countries that they are involved in the space activities, that safety is very important, and they need to be regulated for working or for to have instruction in case of emergencies. I was talking about the case of the Americans, China, some countries, but here in Europe, recently, we have developed this idea of European space law. Well, this is really not an European space law because they are focusing only in a few points. First one, we are in the Europe very clear that we have some problems about the space activities and space regulation. First one, we are the fragmentation of the single market. All the independent European countries, they are developing his programs, but more of them, they are collaborating in the ESA, and all the European Union country is under the system of the space regulation, because the Space Commission has this special attribution about this. Fragmentation of the single market jeopardize the long-term sustainability, impede the competitivity, because we have the Draghi report that say take care about this, because we need to, in Europe, to be more strong about the space activity, collaborate more and develop more. Probably for this reason, in the recent Bremen and ESA meeting, the countries put more money for develop more space activities, because without this, we lose opportunities. And also, in Europe, we take more care about the environmental impact of space activities. This is very, very important for us for avoid all kind of problems. The objective is to create in the European Union a single market for the space sector. For this, should be necessary to create a framework, but at the moment they are not a global framework, or to conduce space operations for this competitive business. Also, should be necessary tracking all the space objects for avoid the possible problems about the space debris. This is in relation of the space traffic management. It's very important. First one is to tracking, to register, and to have a knowledge about the situation. Also, we need to create a risk assessment framework for cybersecurity. It's very, very important. And also create a common method in reference to environmental impact of space activities. This is very, very, very important. Also, reduce the administrative burdens, because if we put extra charge of the bureaucracy in the companies, and the final is good for the lawyers and for the people to working for paper, but it's not so good for the people they are involved in this engineering. For this reason, and for ending the presentation, the European Union make a proposal of European space law in the June 25 of 2025, very recent. It's very, very interesting because traditionally they are a problem in the Lisbon Treaty, in the 18H7 articles, like forbidden the harmonization of the legal regulation. But now we can use another legal basis, the Article 114, for create this internal market. This is the use of the legal question, say, okay, it's not possible to have one law, but we make one market. And in one market, we can develop a situation. It's very, very intelligent to create a situation that during a lot of years is forbidden. At this European space law is structured about three key pillars. Safety is directly in relation to the main theme of this Congress about safety and emergency system. Resilience, more in the contract about the space infrastructure and ensure the business continuity and sustainability. Was defined this the possibility to continue to develop a space orbit with all three pillars, and pending now to negotiate all the points about the legal document. We can develop this natural space law in Europe that we need some years, because we need to regulate authorization for launch, for satellites, for governance aspect, for spacecraft, a lot of points that we need to regulate. In conclusions, space is a field that may need more and better revolutions, and we can working for to have a safety space. We can avoid mistakes, and we can help that the people arrive to the space not only for exploring and to make science, that this is very important, also for to develop this economical area and give profit for all the countries and companies involved in this, with all the safety that we need. Thank you very much.
Thank you very much, Mr. Rafael. That was a very insightful session. You took us quite a journey, a insightful journey at that. Yeah, I would appreciate some more flowers, more applause to Mr. Rafael Gomez Pastrana. Yeah, awesome. Thank you so much for sharing. So yeah, very quickly, in fact, at the very beginning of your session, a quick question dropped. I anticipate there's going to be a question around your portfolio, more of the reason why I had to read it in full. So the question was, now focusing on the crucial legal side with Rafael Laredo, as the space industry expands, the regulatory framework is key to sustainability. Now, what is the biggest legal hurdle you anticipate for asteroid resource utilization or cislunar commerce? I don't know if you're able to get the question or you need time to reflect on it. Hi, Mr. Rafael.
Yeah.
Oh, yes, I just read the question. So I don't know if you got that. Should I go over it again?
Yes,
Should I go over the question again? Can you hear me?
yes, yeah, with some problems about, but if you are some question, I am open to.
Oh, yes. So I mentioned somebody dropped in the comment section, and summarily, the question is, what is your biggest legal hurdle that you anticipate for asteroid resource utilization or cislunar commerce?
Yes, this is one of the most interesting questions, because to develop space activities in asteroid in moon should be the next goal for more companies. Obviously, they are a very interesting question linked to the use of natural resources in the space. By the moment they starting with the American Asteroid Act in 1940, and after that some countries had Japan, Italy, Luxembourg was the first one, and Emirates, they are developing national space activities, and there are some international organizations that say that this is not a specific forbidden in Outer Space Treaty, should be okay to prepare. And now they are in the COPUOS, in the United Nations, a team of people developing. But all the countries that they are involved in Artemis Accords and an ELRS, they are agree with the use of space activities in the space. For this reason, it's a future activities that we need to develop, and this is a possibility to talking about sustainability, risk, and emergency, because we are talking about the space minimum. I believe it's one of the fields that there are more possibilities in a near time, because the main important space resources is the water in the moon that we need, and this should be very important to have more specific regulation for avoid conflict positions about this question in the moon.
Thank you so much, Mr. Raphael. Yeah, for the person that asked the question, I just go to the comment section. If your question has been answered and you have any follow-up question, you might just do well to also ask right away. And just as it has been dropped in the comment section, you can just do well to subscribe to the YouTube channel of MARVECX Aerospace. So that is where you find the recordings. In case you missed probably the initial session or forthcoming session, you might just do well to just subscribe to the YouTube channel where you can just check the replay of all these sessions. And also you can check out our website also for subsequent information that is needed. If you have any other question, this is the moment where you just go to the comment section or you raise your hand so that I can call you. And then yes, you ask your question. Well, while we're waiting for questions, I think I also mentioned that at the end of all sessions subsequently, we'll be giving our highlights. I mean, what stood out from you from each of the session. So you may just go to your comment section, what you gained from Mr. Rafael Arilo Gomez. What do you learn from his session? What are your key takeaways from the session? Like I mentioned, it might just be a line, 2 lines, a sentence. You may just do well to just go to the comment section and do that. I would appreciate that a lot while we anticipate the next session. I mentioned I set a disclaimer initially that the third speaker is coming around, so we'll just would continue the session anyways, but you might just do well to go to the comment section, tell us your highlights. If you have questions, you can also just drop it in the comment section. I look forward to read the highlights. I mean, what stood out from you from what Mr. Raphael has mentioned? All right. Mr. or Miss Kamaldeen Olamilekan. Yes, would you want to meet your mic and ask your question? Olamilekan, please.
Hi. Sorry, am I live?
Oh yes, I can hear you loud and clear. Please proceed.
Okay. I recently heard about the conference via one of my mentors back in Nigeria. So
Awesome.
my question is quick. I noticed the team is kind of linked with sustainable development, right? I'm not experienced and learned in aerospace because I'm a MSc student in mechanical engineering at the University of Hull. So I have background experience with sustainable materials in my prior research while working on bio-based material in addition to kaolin. So then I'm wondering, how is sustainable development combined with AI? How is that going to be the plus to aerospace in general? Because I'm still kind of I'm not quite sure about that.
Yes. No, the relevant question is with the definition of sustainability, with the capability to continuously use the space during more time, not to make an intensive use. I believe that for all the engineering that they are developing the software, hardware about the space capability, it should be very interesting to have this capability to create products and service that they can use continuous during a lot of time. Because if at the final, using this sustainability criteria to access to the space, if your product is clean, is easier to do, they are not the possibility to transport them in space debris. For them, they have more possibilities to access to the space. But at the final, in a competitive world, if you design some products that they are included in this capability of sustainability, should be better for you and your company that collaborate with this kind of product. At the final, they are a selection about the different products. If your product they are including in this sustainability should be better.
Okay. I think that answers that. Thank you.
Thank you.
All right. Yes. If you have any other follow-up questions, you may just do it to also ask. I think the floor is open. And then yes, I mentioned that the program is going to run for 4 days from Thursday to Saturday. Interesting, there is a certificate waiting for those who commit to this program. I repeat, there is a certificate for those who fully commit to this program because attendance is effectively taken across all board, throughout the program. So it will be very interesting for you to participate in all of the program. We have panel session coming up. We have technical sessions coming up. We have quite a robust session across for the next 4 days. So I will enjoy us that throughout the 4 days. Kindly do want to participate and also earn a certificate from MARVECX Aerospace. Okay, thank you so much, Francis, for answering questions in the chat. So if you still have any question, please, we still have 1 more minute to do that. And so far, I don't think I've seen any highlight from any persons. I mentioned highlight, key takeaway from what we've learned, especially from Mr. Raphael. Awesome, thank you so much, Gayatri. Yes, Raphael sir, Raphael, anyone, Raphael sir, session gave us understanding about the need for ensuring the safe use of space resources for the welfare of all nations. Simple, straight to the point. Thank you so much for sharing, Gayatri. I look forward to other sessions, other highlights and key takeaways from Mr. Raphael Arilo. It will actually help those that, probably they just join a mid session, or probably those that, it will actually help those on board as well. So thank you so much, Gayatri, for mentioning. I look forward to at least 2 or 3 more. Thank you so much. 2 or 3 more feedback, 2 or 3 more highlights. It will go a long way.
Thank you.
So for those asking for recordings, I mentioned, please subscribe to our YouTube channel. Recordings is going to be uploaded on our YouTube channel. Please do well to participate on all programs across board to earn the certificates, and also for any other subsequent information, you can just check the website, and all of this is what is already dropped and pinned in the chat box so that you will not miss any session. I'm still looking forward to highlights before we go to the next session. Gayatri has shared hers. Awesome, thank you so much. Gayatri has shared her highlights and takeaway. Please, others, do well to share your highlights, please. It's very, very, very important. Also, if you have any questions, this is also an opportunity for you to ask before we go to the next. Before we go to the next speaker for today. If you are typing, please do well to type fast. I'm sure we are waiting. Actually, I'm waiting for us. Highlights, key takeaway, what you learn from Mr. Gomez Pastrana's class. I think if you have a minute or 2 minutes to do that. I want to believe you are still typing while I go through the portfolio of our next speaker. Actually, still look forward to our highlights, please. That's very important. Okay. While we are still typing, I want to believe we are typing. I want to believe and hope we are typing. We have our next speaker on board, Mr. Roger Hall. Very, very, very interesting man we'll be learning from this afternoon, morning, or evening, wherever you're joining us from. Mr. Roger Hall is a highly experienced aviation professional, an entrepreneur with over 2 decades of expertise, spanning flight operation, business development, and advanced navigation system. He served for more than 21 years in the Emirates airline, where he has an A380 captain, awesome, and a flight operations management leader, as well as the technical pilot and project lead of the Emirates AV group, focusing on advanced navigation and communication system. Later became Vice President of Flight Operations Engineering for the Tata Group Air India, overseeing safe and profitable operational growth towards a 450 aircraft fleet. His extensive experience includes airline communication and monitoring system, policy and procedure development, contract negotiations, and legal due diligence. And on and on and on like that. I had to pause here because Mr. Roger Hall has a lot to deliver for us this afternoon. Ladies and gentlemen, with Clap Innovation, without flowers, I want us to invite Mr. Roger Hall on stage. Mr. Roger Hall, yes, just like other speakers, we have 25 minutes for intensive session, question and answer for just 5 minutes, or 5 minutes for question and answer. Over to you, Mr. Rujahor.
Hi, everyone. Just a sound check. Can you hear me okay?
Yes, we can hear you loud and clear.
All right. I'm going to share my screen then, if I may.
Yes, please. Go ahead.
And if you can let me know if you can see my screen, which is on detecting convective turbulence from space.
Yes, we can see your screen detecting convective turbulence from space.
Great. Thank you so much for inviting me. Happy to be here. And hello, everybody. I'm in Dubai today, where I've lived for 26 years. And it's my pleasure to talk to you today about some new methods in detecting convective turbulence from space. And a little bit about me. I've been in aviation for about 40 years. I started when I was about 17 years old, and I stopped flying around 2020. I've flown most of the Airbus aircraft out there, including the 380, everything except the A300 and the A310, and the Boeing 757 also. And at Emirates, I was a technical pilot on Airbus for 19 of my 21 years while I was at Emirates. And I'm pretty active on LinkedIn, which is how I was invited to this event today, which I'm appreciative of. And if anybody wants to connect with me on LinkedIn, please reach out, and I'll be happy to connect with you there also. I'm the VP of Business Innovation and Integration at a company called WX Fusion, which is a company in Munich in Germany. And we have space and land-based networks that monitor the atmosphere for convective turbulence and some other events, and I will be speaking about those today. I also work as a consultant with IATA on fuel efficiency, and I founded my own company, X-Flash Systems, some years ago to specialize in the aviation domain also. I was a technical pilot and 380 captain at Emirates, 21 years. And I also worked at Tata Group Air India for about 1.5 years as a consultant while they were merging their individual airlines into one unit. So today I'm going to talk about something called CTAS, which is a convectively induced turbulence alerting system. And this is a service for airlines and defense units, potentially also, and also air traffic control. And what we use, this is a connection with space, which is why I was invited here today. We use spectral analysis from space, and these sensors are located on satellites that we use, geostationary satellites, which are located about 36,000 kilometers out in space. And we monitor the Earth's atmosphere for convective turbulence. And when I say convective turbulence, this is associated with heating of the atmosphere. We're not talking about clear air turbulence, which is more to do with polar areas of the Earth. That's where jet streams and clear air turbulence tend to happen, and over mountainous regions. But we're specifically talking today about convective turbulence. So what's spectral analysis? What we're doing is we're looking at the spectrum of light coming from the atmosphere, and we can see little patterns that reveal where the air is unstable or turbulent. And in seeing these changes in how the light is scattered, we can see wind variations and temperature differences, which are common indicators of convective turbulence. So in short, the satellites we use are looking at light patterns to see where the air is rough or smooth. And we also monitor lightning discharge from the ground. Now, this is quite interesting because aircraft by themselves, when they see a lightning flash, the aircraft cannot detect where that lightning came from, where it's geographically located. And that's because to detect where lightning is located, you have to use triangulation. On board an aircraft, you can tell the direction of where lightning came from with sensors, but without triangulation, it's virtually impossible to see how far the lightning is away from the aircraft. And for this reason, lightning detection has to be done from the ground, and that's what we do. So we use spectral analysis from space, and we use lightning detection from the ground. Once we have all this data, every 5 minutes, 24 hours a day, 7 days a week, we have our Met Intelligence, which is a niche form of AI, processed in Munich in Germany, and it's processed every 5 minutes, and the data is then sent to airlines or back to the aircraft, or both, depending on what the airline or organization wants. So there's two ways that we can send data to the aircraft. One is back up to a satellite in space and then down to the aircraft. But the problem with that is there's about 10,000 737s and A320 aircraft that have no SATCOM on board. SATCOM is quite expensive for aircraft. It's about $200,000 to $250,000 for the satellite equipment to be able to receive it, and plus 2 or 3 days on the ground to install it. So many of the discount airlines, they have no way to receive a satellite signal from space to do with this kind of data. So what we can do instead is we can send data back up through a ground-based system, ACARS, which is a civilian data system where we can send the signal back up to the aircraft by VHF. And this is what we can do. We can use space, but if the airline does not have satellite on their aircraft, we can send it up from the ground station up to the aircraft. Now, in order to for the pilot to be able to look at the data on their iPad, most airlines use iPads. They could use some other kind of mobile device, a tablet. But just us sending a signal up to the aircraft into the avionics part of the aircraft, that's not going to get it to the pilot's iPad, which is sitting next to them as they're sitting in their seats. On the captain's side, the iPad is on the left-hand side. And for the first officer, the iPad or mobile device is on the right-hand side. And we have to have a way to get the signal from the avionics part of the aircraft that arrive by ACARS or by satellite. We have to be able to get this by cockpit Wi-Fi to the pilot's iPads. And this is where something called an aircraft interface device comes in, an AID. And the image you can see on the right-hand side, this is one called FOMAX, which is made by Collins Aerospace for Airbus. So most of the Airbuses, Airbus A320s and A330s that have been produced since 2020 come with this box on board, and it may or may not have been activated. It depends on the airline. And this box can have up to 8 SIM cards in it, and those SIM cards are only used for the ground part, when the aircraft's on the ground, to use mobile data to send data back and forth. But these SIM cards and mobile data will not work in the air. So that's why we have to use either satellite or we have to use ACARS VHF back up to the aircraft when it's flying. So all these pieces together form the communication chain. And then we have a map system called CB Global. And this gives you an idea of what it looks like for the airline dispatcher. or for the pilot in the cockpit. Now, our system is real time, and so as I mentioned, every 5 minutes, data is sent to Munich and then back to the airline or up to the aircraft. There's a slight delay of a few minutes once that data is processed and to send it back up again. But this is a real advantage over an aircraft that has no way of seeing a live weather map. Many of the aircraft that are flying, there's no way to get a live weather map up to the pilots. They have radar, and that works okay, but radar is less than perfect. It can't see everything. In order for radar to be able to see a convective cell, there has to be water droplets of a certain size. And if the droplets are too small, the radar waves will not come back to the aircraft in a strong enough signal for the radar to know that there's actually something out there. And this is why we use spectral analysis. So the pilots would use our map as a strategic way of navigating around cells, strategic meaning medium to longer term, perhaps 250 to 400 miles away. And then once the aircraft gets within about 200 miles, they can start to rely on radar more for short-term deviations. Now, we also have a feature where we can send alerts to the airline dispatcher to notify them that one of their aircraft, if they continue on their flight plan track, they are about to intercept some cells ahead. And this could be perhaps 500 or 1,000 miles ahead. And we can notify the dispatcher that one of the aircraft they're looking after is about to have this problem. And we can give them lots of notice. We can even give them, say, 90 minutes notice, and it gives them time to look and check and decide whether they want to take avoiding action or recommend to the crew that they take another look. One of the problems that dispatchers have is information overload. And in large airlines, there could be perhaps 10 or 15 or even 20 dispatchers on duty at one time. Each one of them is responsible for looking after a certain number of aircraft in their region, and they can get distracted and suffer information overload. So we have a system, that box on the left-hand side, the X-Flash box, which will light up a different color depending on the severity of the alert, with the flight number and a reference number of the cell that is ahead. And then they can take avoiding action. Here's what it looks like in the aircraft. You can see the pilot's EFB on the left-hand side. This is from an Embraer aircraft. You can tell from the control column that shape is an Embraer aircraft shape. And this iPad is fairly low down. Other ones could be higher up on the ledge above. You see where the handle is. To the left of that is another mounting position that some airlines choose. And this is where, for aircraft that do have update capability, they do have an AID, they can have a near real-time map of what's happening in the weather. Here's a closer look of how an area over India might appear to a pilot. You can see the central part of India is fairly clear in this image, but then up to the northeast, you can see some blue dots, those are lightning, and you can see some red lines, those are mature cells. And lightning is a very good indication of turbulence, and the red outline there is also something to stay away from. So we would recommend to the pilots that they would stay away from this. Also, looking down at the south part of India, just north of Sri Lanka, you can see, again, some blue dots and some red regions, and these are indicating turbulence to the crew. And these are things that radar may or may not see. Further to the east, you can see some orange areas. These are less hazardous cells that are likely not going to appear on radar because they're not significant enough for radar to see, but we do see them. Here's another close-up of a weather region with the red material cells and some blue dots and some orange, less impactful cells. And you can see an arrow coming out of the region pointing to the northwest, to the left, top left. And that is called nowcasting. So that dashed line that you can see to the left of those solid images, this is where the cells will be 1 hour from that time. So this is our definition of nowcasting. We're looking 1 hour ahead. So this is helpful to the crew because when they decide which direction to deviate, either left or right, they can see which way the cell is moving and they can determine which direction makes the most sense to avoid these cells. And this is something that radar does not have. There's no such thing as nowcasting with radar. This is another view of a map that a dispatcher would be looking at. The red contours are mature thunderstorms. The blue is areas of intense lightning. And the crosses within the blue areas are actual lightning events, individual lightning strikes. And then the cyan areas and the yellow lines are routes that the aircraft flew at various times. And these are reports that we can provide to airlines. If they have events and they're trying to figure out what happened, we can produce an event, a report for the airline, for their safety department, and they can investigate further and prevent it from happening again, usually through pilot education. So here's some of the advantages of these systems. Unlike some other systems that are out there, we don't require any aircraft to first experience turbulence in order to report it. There are some systems out there that have accelerometers on board. They either use the accelerometer, which is installed by the manufacturer when the aircraft was made, or by accelerometers on the mobile device or the iPad itself. And they report back when an aircraft experiences some accelerations. They report to other aircraft. The issue with those kind of systems is they do require kind of a guinea pig aircraft to be ahead of the other aircraft in order to first experience turbulence. And this is something that we didn't want to do. So we developed the system another way. And with our system, all aircraft are treated equally. And they all get the same level of service and the same level of safety. There's no dedicated aircraft equipment needed on board, and we do not use accelerometers. And we do not require the aircraft to be equipped with broadband SATCOM, because as I mentioned, it's very expensive. VHF cars is good enough. And most of the aircraft out there today do have VHF cars, although they do need that AID, aircraft interface device also. Our map updates are very small in size, and we use GeoJSON data instead of pixels. So these are not pictures we're sending to the aircraft. They are actual bits and bytes of data that are in a special code. And we do not require busy airline dispatchers to be looking at the screen because we have supplemental systems which are attention getters, which alert the dispatchers and other airline staff to any problems that could occur in the future. So for any airlines that are out there or ATC services, here's what we request in order to provide a free evaluation to them. They identify about 5 regular company flights that are exposed to en route weather dangers. And then those are the flights that are selected for the trial. We need information regarding the communication capability of the fleet. Does it have broadband spectrum? Does it have an aircraft interface device? Somebody needs to mute themselves there. We need an updated flight plan route feed, data waypoints from the airline, and the airline gives that to us. And then we make a personal visit, no matter where they are in the world, to install a small number of boxes, notification boxes. And these are IoT devices, Internet of Things devices. There's a brief written evaluation agreement that is signed by both parties, and then they get their free evaluation. And there's no commitment after 3 months. If they don't think that it works in the way that we said it would, then the evaluation can end and we don't go any further. Now, this is an additional system that we're working on, and I'm going to show you a very brief video. It's only about 30 seconds long. We're nearly done here. And this is a tool for the dispatcher where our system will automatically plan a route through thunderstorms, through cells. And this is something nobody else has to our knowledge. So we're taking the data from space and the data from the ground, lightning, and we are planning the routes around the cells for the airline, and we don't have to rely on radar. The green aircraft is an aircraft with our system, and the blue aircraft is an aircraft without our system, and all they have is radar. So let's take a look at this. Let's go back here. Sorry about that. So you can see the blue aircraft starting to deviate now. All they have is radar, and they can't see as far ahead as our green aircraft can. And you can see the green aircraft ends up far ahead of the blue aircraft. And this is saving time, fuel, and money. And this is what airlines want to do. So we're making the whole industry more efficient with this system for airlines who choose to use it. And now I would be happy to answer any questions anybody has. Thank you very much.
Thank you so much, Mr. Gavor. That was very short, precise, and yeah, straight to the point. If we have any question, this is the moment where we ask question, feedback, or you need clarity at any point. You might just do well to ask these questions. Questions. At the same time, I just go to the comment section and also, yeah, I still look forward to a highlight, key takeaway from Mr. Roger Hall's session or previous session as well. So I'll just give like 1 minute silence for us to reflect and ask any question whatsoever.
Either I confused everybody or I answered all the questions. So no problem. If there's any questions later on, just you can contact me through the regular channels here or on LinkedIn. I'll be happy to answer them for you.
Awesome. Thank you so much, Mr. Roger Hall. Yeah, while we're waiting for questions and highlights from this session, for those just joining us, you are welcome. I am told to give a shout out to Reverend Dr. Paul Kolawole. You can just give a thumbs up or just to show you on the call, sir. I have to give a shout out for you joining this call. It's so wonderful to have you on the call. Yes, you want to say something, sir? You want to say hi to us? Your mic is unmuted, you can go on.
I was recognized in a meeting, and they want me to do a thumb up, but it's not to the thumbs up.
No, I
Just
just
to
wanted to confirm if you are here, then give you a platform to talk. No problem, sir. Please go ahead, sir.
oh, thank you.
Please go ahead and speak. I just wanted to confirm you are with us. Please go ahead and speak, sir.
Sorry, are you referring to me?
Yes, please.
Oh, thank you. I'm sorry. Yeah, I sorry for joining late. I have a privilege of knowing one of the group team, and I promised I will join the line. I mean the group as soon as you commence. But it has been a busy day for me. I just had a little time to join, so I'm just trying to understand the nature of this program. Though he told me, I mean, Marvelous. He told me briefly about the operation, but I'm yet to understand the in-depth. So I will still appreciate me listening to all of the teachings, all of the comments. Maybe tomorrow, maybe next, I will make some comments. Thank you.
No
I
problem,
sincerely
sir.
appreciate your efforts at making life conducive and convenient to as many people as you can reach. So I commend your work. I say well done, and I pray the Lord will continue to strengthen you, strengthen your focus, and help you to do much more for the generality of the masses and for the whole world. Thank you. Well done. Thank you.
Thank you so much, Reverend Dr. Paul Kolawole. Thank you so much. MARVECX
My pleasure.
Aerospace recognize your presence, and then they specifically asked that I'll give a shout out. Maurice, I wanted to confirm if you're on the call, so to give a thumbs up there to give you a platform to speak as well. Thank you so much, sir. We've actually had two previous speakers spoken. You might want to check the replay of the session on YouTube. I believe MARVECX is going to send the link and also give you detailed information concerning what you need to know. But thank you so much for joining. We appreciate your fatherly role and your guidance, especially to MARVECX and the MARVECX Aerospace as a whole.
All right. Thank you. It's a pleasure too. Thank you. I appreciate you too. Thank you.
Thank you so much, sir. So, Mahi, okay, Mahi is dropping an highlight. Thank you so much. I need to meet you, sir. I think you have
Thank
some
you.
background noise. Yes.
I appreciate.
Oh, sorry. Okay. Yeah. So, Mahi, you dropped an highlight. Thank you, Roger, sir. Your talk showed how aviation is becoming smarter by combining spectral data from space, ground-based lightning monitoring, and AI-driven analysis to give pilots a real-time turbulence and thunderstorm alerts, improving flight safety and efficiency. As a student, I learned a lot. Thank you so much for sharing, Mahi. It shows you're listening. It shows you are here. And then, yes, this is a feedback to probably those that just joined the call, and also to the facilitator as well, the guest speaker as well, that yes, he has actually shared an insightful section with us. So if anybody also have any other feedback or any other highlights or summary to share, please do want to make use of the comment section. And yes, the platform is also still open for questions. So in the next 2 minutes, we'll be going for a 15-minute break. And I was told to also mention it to us. That we might be closing earlier than communicated because we have a long day tomorrow. We have a series of speakers that are ready to also gist to us, from their wealth of experience. So we might close early today, but I believe with the speakers we've had so far, we have learned enough, and at least we've actually hit the ground running, also ahead of the momentum for the next couple of days. Somebody has dropped, Francis to be precise, has dropped in the comment section. Yes, Francis drop in the comment section if you're interested in a certificate, and just make sure that you are able to participate in all of the sessions in the couple of days, and then you fill in the form that is in the comment section. So in the absence of any other highlights, feedback, summary, we'll be going for a 15-minute break. So let's say we'll be back by exactly 6:20. So in the break, you might just do it. You might still want to drop your summary. You might still want to drop your question. You might still want to drop your feedback and so on and so forth in the comment section. But in the 15-minute break, you can just do well to check the website that was shared, MARVECX.com. You might just do well to check the YouTube channels on previous sessions we've had. And you might just do well to also reflect on what has been shared. Go through your notes, what has been shared. And if you have any question, you might just do well to do that as well. So yes, 15 minutes break. So let's be back by 6:20 to make sure to continue the session. In the meantime, I would like to confirm if Mrs. Raina Faber is on the call. Mrs. Raina Faber, please confirm if you're on the call. You may want to raise your hand, give a thumbs up, just to notify us on the call.
Hi.
Awesome.
Hi.
Hi.
Here, I'm here.
Yes.
Just connected.
Thank you so much. I just wanted to confirm you're on the call. So you'll be coming on immediately after the 15 minutes break, exactly 6:20 p.m.
Okay.
W8. Thank you so much.
Thank you.
All right. So you might just want to take a coffee, water, or you take a walk, or you reflect on your note, or you go through whatever channel it's been. 6:20. Thank you so much.